At 6:15 on the morning of June 6, 1944, Greta Heinrich Seal crawled into position behind an MG-42 machine gun overlooking Omaha Beach. The air carried the sharp smell of salt mixed with diesel fumes drifting from ships offshore. A thin fog clung to the surface of the English Channel. Seal was 20 years old, a former farm laborer from Lower Saxony who had been drafted into the Wehrmacht 2 years earlier. He had trained as an artilleryman but now found himself assigned to an infantry strongpoint along the Normandy coast. His hands were steady as he checked a weapon. Ammunition belt seated, barrel locked in place, sights aligned precisely with the waterline below. He had fired thousands of rounds during training exercises. He had never fired at another human being. Below him, still hidden in the pre-dawn darkness, the largest invasion fleet in human history was closing in on the coast of Normandy. More than 5,000 ships, 11,000 aircraft, and 156,000 soldiers were moving toward the shore. The Allied forces were about to attempt the most ambitious amphibious assault ever undertaken. Seal's position was designated Widerstands 62, a reinforced concrete bunker embedded into the bluffs overlooking the sand. The Germans referred to these fortifications as resistance nests. They were designed to create overlapping fields of fire that would transform any beach landing into a killing ground. Seal's bunker sat roughly 40 meters above sea level. From that height, he commanded a clear field of fire across nearly the entire eastern stretch of Omaha Beach, close to 2,000 meters of exposed sand. His weapon was loaded with belted 7.92 by 57 millimeters ammunition, the standard German infantry cartridge, the same round the Army had used since the turn of the century. Thousands of rounds were stacked beside him in metal ammunition boxes. His assistant gunner stood ready, prepared to feed belt after belt into the receiver without pause. The landing craft emerged at dawn, gray silhouettes cutting through the gray water. Seal could hear the low drone of their engines blending with the crash of waves against the shore. Through his binoculars, he watched the craft draw closer. He could make out soldiers packed tightly inside, standing shoulder to shoulder, waiting for the ramps to drop. The first ramps fell at approximately 6:30 a.m. American soldiers spilled into the surf, each man burdened with nearly 60 pounds of gear. They waded through water that often reached their chests. They were completely exposed. The beach offered no cover, no protection from a gun's position high above. Seal squeezed the trigger. The MG-42 exploded to life with its unmistakable sound, a continuous, ripping roar unlike any other weapon on the battlefield. Firing at a rate of nearly 1,200 rounds per minute, individual shots blended into a single mechanical scream. Over the next 9 hours, what happened in that sector would earn Seal the nickname the Beast of Omaha. But the weapon that made this devastation possible had a story that began years earlier, far from any battlefield, in a factory that had nothing to do with war. The MG-42 was not designed by seasoned weapons experts. It was not produced by a prestigious arms manufacturer with generations of experience. Instead, it was conceived by mechanical engineers who knew almost nothing about machine guns. They worked for a company whose primary business was manufacturing sheet metal lanterns. The factory itself stood in a small provincial Saxon town that most Germans had never heard of. The lead designer had never fired a weapon in combat. He had never served in the military. His expertise lay in industrial production methods, not in killing. And yet, his creation became the blueprint for nearly every general-purpose machine gun that followed, including weapons still carried by armies around the world more than 80 years after it first appeared on the battlefield. Direct descendants of his design are used by soldiers on every continent. This is a story of how a manufacturing innovation that saved roughly $100 per weapon changed the way wars are fought. This is a story of the MG-42. The problem began with the MG-34. In 1934, the German military introduced what they called the Einheit Smashträger, the universal machine gun. The idea itself was revolutionary. Traditional military doctrine separated machine guns into distinct categories. Light machine guns were portable weapons carried by infantry squads for mobile combat. Heavy machine guns were crew-served weapons mounted on tripods, intended for sustained fire from fixed positions. Aircraft machine guns were specialized designs optimized for aerial use. Anti-aircraft weapons had entirely different requirements. German planners proposed something radically different. They wanted a single weapon capable of fulfilling all these roles. One gun that could be carried by infantry on a bipod, mounted on a tripod for sustained fire, installed in vehicles and aircraft, and adapted for anti-aircraft defense. One design, one training system, one logistics chain. The result was a Maskeningewehre 34, better known as the MG-34. At the time of its introduction, it was arguably the most advanced automatic weapon in the world. The MG-34 was an air-cooled, recoil-operated machine gun chambered for standard German 7.92mm Mauser cartridge. It fired at approximately 850 rounds per minute, significantly faster than comparable British or American machine guns. It could feed from 50-round belts that linked together for continuous fire, or from 75-round saddle drum magazines for mobile operations. The weapon featured a quick-change barrel system. A trained gunner could replace an overheated barrel in under 15 seconds, allowing for sustained fire without catastrophic overheating. The sights were finely adjustable for both range and windage. The trigger mechanism allowed the operator to select between semi-automatic and fully automatic fire. Most importantly, the MG-34 could adapt to multiple battlefield roles through various mounting systems. On its integral bipod, it functioned as a light machine gun. Mounted on the Lafayette tripod, it became a medium machine gun capable of accurate fire at distances exceeding 1,000 meters. Specialized mounts allowed it to be installed in tanks, armored vehicles, and aircraft. The German military was immensely proud of the MG-34. They believed it provided a decisive advantage over potential enemies, and in many respects, they were right. But the MG-34 suffered from a critical flaw that only became apparent as Germany prepared for a large-scale war. The weapon was extraordinarily difficult to manufacture. The MG-34 was, above all else, a machinist weapon. Nearly every component required precision machining from solid blocks of steel. The receiver was milled from a single billet of high-grade steel. The bolt assembly consisted of dozens of finely fitted parts. The barrel extension, feed mechanism, and trigger group all demanded the careful work of highly skilled craftsmen using expensive machine tools. Each MG-34 required approximately 150 man-hours to produce. That meant a single worker, operating full-time, could manufacture perhaps one weapon per month. In practice, production was divided among specialists at various stages, but the total labor investment remained unchanged. The cost was 327 Reichsmarks per unit. At contemporary exchange rates, this was roughly equivalent to 130 American dollars. To put that in perspective, an average German factory worker earned roughly 150 Reichsmarks per month. A single MG-34 therefore cost more than 2 months of an ordinary worker's wages. The weapon also required approximately 49 kilograms of raw materials, most of the high-grade steel alloys containing metals Germany had to import from abroad. As political tensions escalated through the late 1930s, access to those materials became increasingly uncertain. Even more critical was the demand for skilled labor. Germany possessed excellent machinists and toolmakers, but their numbers were limited. Every machinist assigned to MG-34 production was a machinist not working on aircraft engines, tank components, artillery systems, or any of the thousands of other precision parts required by a modern military. The Wehrmacht recognized the problem. Staff planners calculated their projected machine gun requirements and compared them to actual production capacity. The figures did not align. Germany simply could not manufacture enough MG-34s to equip the army it was building. In February 1937, the German Army Weapons Agency issued a formal request for proposals. They wanted a new universal machine gun that could match the MG-34's combat effectiveness while being significantly cheaper and easier to manufacture. 3 companies received development contracts. 2 were expected choices. Rheinmetall Borsig of Smyrna was one of Germany's premier arms manufacturers, producing military equipment since the 19th century. The company had deep experience with machine guns, artillery, and armored vehicles, along with the engineering staff production facilities, and institutional knowledge needed to design a new weapon. Stubbs of Erfurt was another established arms producer. They had supplied military hardware for decades and maintained close relationships within Germany's procurement system. The third company was unexpected. Metal. UND Lackware and Fabric Johannes Grossfuss was located in Dobeln, a small Saxon town with a population of around 20,000. The company's name translated to Metal and Lacquerware Factory, Johannes Grossfuss. Its primary business was manufacturing pressed and stamped sheet metal products. Their most recognizable item was lanterns. They had never designed a weapon of any kind. They had no experience with military contracts and no reputation in the arms industry. What they did have was deep expertise in the manufacturing process most weapons designers had largely ignored. They knew how to stamp metal. The man chosen to lead their machine gun project was Dr. Werner Gruner. He was 33 years old, a mechanical engineer who specialized in mass production methods. Gruner was born on June 7, 1904, in the village of Treppich, a tiny settlement that would later be absorbed into the town of Colditz. His father was a schoolteacher. The family was not wealthy, but education was strongly valued. From an early age, Werner showed a clear aptitude for technical subjects. He attended the Real Gymnasium in Dobeln, a secondary school emphasizing mathematics and science. In 1923, he completed his secondary studies in Leipzig and enrolled at the Technical University of Dresden. From 1923 to 1928, Gruner studied mechanical engineering, focusing on manufacturing processes and production efficiency. He completed his doctorate and remained at the university for 2 additional years as a research assistant, further refining his expertise in mass production techniques. In 1930, he joined the Grossfuss Company as a technical designer. Gruner knew nothing about weapons. He had never served in the military. He had never fired a machine gun. His expertise lay entirely in stamping sheet metal into functional shapes using hydraulic presses and simple tooling. This apparent weakness would become his greatest advantage. The other 2 companies approached the challenge as weapons designers. They attempted to improve existing machine gun concepts, refining mechanisms that had proven effective in earlier designs. Their focus remained on ballistics, metallurgy, and battlefield performance. They assumed that a machine gun had to be built using traditional methods, with components machined from solid steel blocks. Gruner approached the problem as a manufacturing engineer. He asked a different question. Instead of asking how to build a better machine gun, he asked how to build a machine gun that was better suited to mass production. As part of his initial work, Gruner made an unusual decision. He enrolled in a German Army machine gun training course. For several weeks, he trained alongside soldiers learning to operate the MG-34. He fired thousands of rounds. He observed how gunners carried their weapons, how they set up firing positions, how they fed ammunition belts, and how they replaced overheated barrels. He paid attention to details traditional weapons designers often overlooked. How did soldiers maintain their weapons in the field? Which parts failed most frequently? Which procedures took too long under combat conditions? What could go wrong when everything depended on the gun continuing to fire? He spoke directly with experienced gunners about their frustrations with the MG-34. They told him about its sensitivity to dirt and dust. They complained about components that were difficult to replace and described moments when the weapon failed them at critical times. After completing the course, Gruner returned to Dobeln and began designing from first principles. Traditional machine guns relied on precision machine components cut from solid steel billets. Skilled machinists started with large blocks of high-grade steel and carefully removed material until a final shape emerged. The process was slow, expensive, and dependent on highly trained craftsmen. It also wasted an enormous amount of steel. Much of the original billet ended up as metal shavings scattered across the factory floor. Gruner proposed something radical. He would build a machine gun primarily from stamped sheet metal components, using the same techniques Grossfuss employed to manufacture lanterns. Sheet metal stamping worked fundamentally differently from machining. Instead of removing material, flat sheets of steel were pressed into three-dimensional shapes using hardened steel dies. The process was fast. A hydraulic press could form complex parts in seconds. The components required minimal finishing and could be produced by relatively unskilled workers following straightforward procedures. Stamped parts also used material far more efficiently. There was very little waste. A flat sheet entered the press, and a finished component emerged. Nearly all the metal ended up in the final product. Contrary to widespread belief, stamped components could be extremely strong. The stamping process compressed and work-hardened the steel, increasing its structural strength. A properly designed stamped part could equal or even surpass the strength of a machine component made from the same grade of steel. Weapons experts were deeply skeptical. They argued that a stamped metal machine gun would be flimsy, unreliable, and prone to failure under the extreme stresses of automatic fire. They emphasized that the forces involved in such weapons were immense, with thousands of pounds of pressure generated repeatedly, shot after shot, at rates approaching hundreds of cycles per minute. Hundreds of times per minute. Surely stamped sheet metal could never withstand such punishment. Gruner was determined to prove them wrong. Working with a small development team that included a gifted small arms designer named Kurt Horn, who had previously worked at Mauser, Gruner set out to create a new machine gun built almost entirely from stamped steel. Only the most critical components, the barrel, the bolt, and a handful of high-stress parts, would be machined from solid steel. Everything else would be stamped, pressed, riveted, and spot-welded together. The new design incorporated an unconventional operating system. Instead of the rotating bolt used in the MG-34, Gruner's weapon employed a roller locking mechanism. Two steel rollers mounted in the bolt head engaged matching recesses in the barrel extension. When the weapon fired, gas pressure forced the bolt rearward, but the rollers delayed its movement, preventing the action from opening until the bullet had exited the barrel and chamber pressure dropped to safe levels. Once that happened, the rollers were cammed inward, unlocking the bolt and allowing the mechanism to cycle and chamber the next round. The system was elegant, reliable, and perfectly suited to stamp construction. In time, it would influence numerous other firearms designs around the world. By October 1937, all three competing companies submitted their proposals. Rheinmetall Borsig and Stubgen both presented gas-operated designs that followed conventional machining philosophies. Grossfuss submitted something entirely different. The evaluation board examined all three entries, reviewing performance specifications, manufacturing complexity, and projected production costs. The decision surprised many observers. The Grossfuss design was selected for further development. The Lantern makers had outperformed Germany's established weapons manufacturers. Initial trials of the Grossfuss prototype in April 1938 revealed shortcomings that needed to be addressed. The feed mechanism required refinement. The barrel change system was not yet fast enough. Some components showed excessive wear during prolonged firing tests. Gruner and his team returned to the factory and tackled each issue systematically. They tested, modified, retested, and refined the design again and again. Deliberately, they kept the weapon's external appearance and handling characteristics similar to the MG-34. This was no accident. Soldiers already trained on the MG-34 could transition to the new gun with minimal retraining, and existing mounts, accessories, and support equipment would remain compatible. By February 1939, the improved prototype, now designated the MG-39, was ready for extended trials. The results exceeded every expectation. The stamped steel construction that critics believed would fail proved more durable than the precision-machined MG-34. The new weapon was far less sensitive to dirt, dust, and debris. It continued to function under conditions that caused a finicky MG-34 to jam. Tests conducted in sand, mud, and extreme temperatures demonstrated superior reliability. The stamp components flexed slightly under stress instead of cracking, and the looser tolerances inherent in stamp construction actually improved reliability, allowing the mechanism to keep working even when fouled. The production figures told an equally compelling story. The MG-34 required approximately 150 man-hours to manufacture. The new Grossfuss design required just 75, half the labor for the same battlefield role. The MG-34 consumed about 49 kilograms of raw materials per weapon. The new design used only 27.5 kilograms, nearly cutting steel consumption in half and freeing valuable strategic materials for other purposes. The MG-34 cost 327 Reichsmarks per unit. The new weapon cost 250 Reichsmarks, a 24% reduction that translated into millions in savings as production scaled up. But those savings came with something else, something that would haunt Allied soldiers for the rest of the war. The new gun fired faster than any infantry weapon in existence. The MG-34's rate of fire was around 850 rounds per minute, already faster than most Allied machine guns, which typically fire between 450 and 600 rounds per minute. The American Browning M1919 fired at roughly 500 rounds per minute. British Vickers guns were similar. The new Grossfuss design fired at 1,200 rounds per minute, with some variants reaching as high as 1,500. This extraordinary rate of fire was intentional. German tactical doctrine emphasized suppressive fire, the ability to pin enemy troops in place while assault units maneuvered. Military analysts studying combat footage concluded that enemy soldiers were usually exposed for only brief moments as they moved between cover. Maximizing bullet density during those fleeting windows was critical. A weapon firing at 1,200 rounds per minute put twice as many bullets into the target area as one firing at 600. In the few seconds when an enemy soldier was visible, that difference could be fatal. The engineering challenges were enormous. At 1,200 rounds per minute, the weapon cycled 20 times per second. The bolt traveled back and forth faster than the human eye could follow. Tremendous forces were generated and absorbed with every cycle. The barrel heated rapidly as bullets passed through at extreme velocity. Gruner and his team addressed each challenge methodically. They developed a rapid barrel change system that allowed a trained gunner to replace a barrel in under 6 seconds. A lever on the side of the receiver unlocked the barrel. Wearing an asbestos glove, the gunner pulled a hot barrel free, inserted a fresh one, and locked it in place automatically. With practice, the entire process could be done without taking the gunner's eyes off the battlefield. They also refined a feed system capable of handling ammunition belts smoothly and reliably at extreme cyclic speeds. The mechanism used a roller-driven arm inside the receiver cover that moved back and forth with each cycle, advancing the belt one round at a time. The design was so efficient and dependable that it became the basis for many later machine guns. The result was a weapon capable of sustained fire rates that would have destroyed earlier designs. Where other machine guns overheated, jammed, or shook themselves apart, the MG-39 simply kept firing. A limited production run of roughly 1,500 improved weapons, designated the MG-39/41, was completed in 1941 for combat trials. German infantry units tested them under real battlefield conditions on the Eastern Front. The reports were overwhelmingly positive. Soldiers praised the new gun for being lighter than the MG-34, far more reliable and easier to maintain. Above all, they emphasized the devastating effect of its rate of fire. In early 1942, the German military officially approved the design for full-scale production. Manufacturing contracts were awarded to Grossfuss, Mauser, and other partner firms, marking the beginning of one of the most feared weapons of the Second World War. Gustloff Werke, Steyr-Daimler-Puch, and several other firms joined production. The weapon officially entered service as the Maskeningewehre 42, the MG-42. In May 1942, the MG-42 saw its first major combat use. Units of the German Afrika Korps deployed the new machine gun during the Battle of Gazala in Libya. British troops encountered something entirely unfamiliar. This was a machine gun that sounded like nothing else on the battlefield. At such an extreme cyclic rate, The human ear could not distinguish individual shots. The brain could not process 20 separate reports per second. Instead of the familiar rattling bursts of conventional machine guns, the MG-42 produced a continuous tearing noise, like heavy fabric being ripped apart. British soldiers said it sounded like cloth tearing. Others compared it to a buzz saw cutting through wood. Nicknames spread almost immediately. British troops called it the Spandau, a holdover from the First World War, when German machine guns were produced in the Spandau district of Berlin. American soldiers called it Hitler's buzzsaw. Soviet troops on the Eastern Front referred to it as the linoleum ripper because the sound reminded them of flooring being torn up. German soldiers had their own names for it. They called it the Knochensage, the bone saw, for the damage it inflicted on human bodies. They called it the Hitlersage, Hitler saw. They also called it the St. Sage, the singing saw, for the high-pitched, almost mechanical whine of its fire. By mid-1942, the MG-42 was being deployed on every front. Production ramped up with remarkable speed. German factories produced roughly 35,000 MG-42s in 1942, despite it being only a partial year of production. That number jumped to 116,725 in 1943. In 1944, even as Allied bombing intensified and German industry came under relentless pressure, production peaked at approximately 200,000 weapons. In the final months of the war, with Germany's industrial base collapsing, factories still managed to turn out 61,877 MG-42s in 1945. By the end of the conflict, more than 400,000 MG-42s had been manufactured, although the original intent had been to replace the MG-34 entirely. Both weapons remained in production throughout the war. The MG-34 continued to serve, particularly in roles where the ability to use drum magazines was advantageous. But the MG-42 became the defining German infantry weapon of the Second World War. Its psychological impact on Allied soldiers was profound. The sound alone was terrifying. Nothing in their training had prepared them for a weapon that screamed continuously instead of firing in recognizable bursts. Veterans later described a visceral, almost instinctive fear triggered by the noise, a reaction that was difficult to suppress through discipline alone. The reality was even worse than the sound suggested. At that blistering rate of fire, a sustained engagement lasting just 30 seconds could put more than 600 bullets into the beaten zone. Against exposed infantry, the results were devastating. The MG-42 reshaped German infantry tactics. While American and British doctrine emphasized the individual rifleman as the core of the infantry unit, with machine guns in a supporting role, the Wehrmacht built its squads around the machine gun. German tactics placed the MG-42 at the center of every engagement. Riflemen existed primarily to carry ammunition, protect the gun crew, and eliminate enemies already suppressed by machine gun fire. A typical MG-42 crew consisted of 6 men. The gunner operated the weapon, controlling fire and selecting targets. The assistant gunner fed ammunition belts and watched for threats the gunner might miss, and he was trained to take over instantly if the gunner was killed or wounded. One soldier carried the Lafayette tripod for sustained fire positions. 3 additional soldiers carried spare barrels, extra ammunition, tools, and other essential supplies. Every member of a German infantry squad understood that keeping the MG-42 firing was their primary responsibility. Ammunition consumption was enormous. At 1,200 rounds per minute, a prolonged engagement could exhaust a squad's entire ammunition supply in minutes. German logistics devoted significant resources to keeping MG-42 positions supplied. Infantry units stockpiled ammunition at defensive positions. Resupply efforts prioritized machine gun belts above almost everything else. The weapon delivered results that justified the expense. In defensive roles, a single MG-42 could dominate open ground for hundreds of meters in every direction. In offensive operations, It provided suppressive fire that pinned defenders in place, while assault teams maneuvered to flanking positions. On the Eastern Front, where distances were vast and cover was often limited, the MG-42 proved especially lethal. Soviet infantry assaults frequently ran into walls of automatic fire that shattered attacking formations before they could close with German lines. Soviet soldiers learned to fear the distinctive sound and developed tactics specifically aimed at neutralizing MG-42 positions before attempting any advance. At Monte Cassino in Italy, German defenders held the ancient monastery for nearly 4 months. From January to May 1944, American, British, Polish, and New Zealand forces launched repeated assaults. Each attack was met with MG-42 fire from fortified positions in the hills above. German gunners swept entire approach routes with sustained fire, cutting down wave after wave of attackers. The Allies eventually resorted to massive aerial bombardment, reducing the monastery to rubble. Even then, German machine gunners continued fighting from the ruins. In the hedgerow country of Normandy after D-Day, MG-42 teams turned the dense bocage into killing grounds. The Norman hedgerows were ancient field boundaries, thick walls of vegetation growing atop earthen banks that divided the countryside into a maze of small, enclosed fields. The narrow gaps between hedgerows became natural kill zones. A single MG-42 position at the end of a sunken lane could halt the advance of an entire company. American infantry quickly learned to listen for the distinctive sound and dive for cover the moment they heard it. The situation became serious enough that the United States War Department produced a training film specifically to address the weapon's psychological impact. War Department Film Bulletin Number 181, titled Automatic Weapons, American versus German, was released in 1944. The film was intended to help soldiers cope with their fear of the MG-42. The narrator openly acknowledged that American troops were intimidated by its sound. He showed footage of the German weapon firing, then demonstrated American machine guns for comparison. He assured viewers that the German gun's bark was worse than its bite. He explained that American weapons, while slower firing, were supposedly more accurate and easier to control. The film included a dramatized scene in which a newly arrived replacement soldier panicked and cowered under MG-42 fire, while his more experienced comrades remained calm and composed. The message was unmistakable. Fear the sound was a rookie mistake. Veteran soldiers, the narrator implied, knew better. The film closed with final reassurance that American weapons were superior. The German gun is good, he said, but ours is better. Historians later noted that the film functioned more as propaganda than as genuine training material. Claims that American weapons were more accurate were questionable at best. The suggestion that the MG-42's extreme rate of fire somehow made it less dangerous was simply false. The reality was that the MG-42's bite was devastating. Tens of thousands of Allied soldiers were killed or wounded by the weapon over the course of the war. The training film may have helped some men manage their fear, but it did nothing to change a machine gun's fundamental lethality. On June 6, 1944, Heinrich Seal demonstrated exactly what the MG-42 could do in the hands of a determined gunner with a clear field of fire. Seal began firing as the first landing craft approached Omaha Beach. He fired in controlled bursts of 6 to 8 rounds, sweeping the waterline where American soldiers struggled through the surf. He watched through the sights as men fell. He kept firing. His assistant gunner fed belt after belt into the weapon. When the barrel became dangerously hot, they replaced it. Seal had several spare barrels ready. When ammunition supplies ran low, other soldiers brought more from storage deeper inside the bunker. The American soldiers on the beach had almost no effective means of response. They were wading through water while burdened with heavy equipment. Many had been seasick during the crossing and were weak, exhausted, and disoriented. Their rifles were often soaked with seawater and failed to function. The artillery and naval gunfire meant to suppress the German defenses had largely missed its targets. Seal fired for hours. He later recalled that at some point he stopped thinking of the figures on the beach as men. They became targets, abstract shapes to be engaged and eliminated. The MG-42 made it possible to fire at so quickly, that the human mind retreated from the horror of what was happening. By his own account, SEAL fired approximately 13,500 rounds of machine gun ammunition during the battle, along with another 400 rounds from his rifle when the MG-42 required reloading or barrel changes. American casualty estimates for Omaha Beach exceeded 2,000 killed and wounded on D-Day alone. German records and post-war analysis indicate that SEAL's position was responsible for a significant share of those losses. Whether his personal claim of killing or wounding more than 1,000 Americans, possibly as many as 2,000, is accurate remains a matter of debate among historians. Many scholars consider such figures implausible, given that total Allied casualties across the entire 6-mile length of Omaha Beach numbered around 2,400. What is certain is that MG-42 positions devastated the American assault waves that morning, and SEAL's bunker at Wider Stanza 62 was among the most lethal. The American response to the MG-42's effectiveness went far beyond psychological warfare films. Military planners and weapons designers studied the German machine gun in depth. Lessons learned from its shaped post-war development programs. In the late 1940s, U.S. ordnance engineers began work on a new general-purpose machine gun to replace the aging Browning designs that had served since the First World War. Captured MG-42s were examined in meticulous detail. Engineers stripped them down to individual components, measured and weighed every part, and fired thousands of rounds through them to understand their behavior. American designers identified several features worth copying. The feed mechanism was exceptionally reliable and efficient. The quick-change barrel system surpassed anything then in American service. The stamped steel construction demonstrated that precision machining was not a prerequisite for an effective military weapon. The resulting American design, known during development as the T-161E3, combined elements drawn from multiple sources. Its operating system was heavily influenced by the German FG-42 paratrooper rifle, which used a tilting bolt mechanism. The feed system was taken almost directly from the MG-42. The overall philosophy of stamped steel construction came straight from Werner Gruner's work at Grossfuss. The weapon was standardized in 1957 as the M60 machine gun. American soldiers carried it through the Vietnam War, where it became one of the conflict's iconic weapons. They nicknamed it the Pig, a reference to both its weight and its voracious appetite for ammunition. The M60 remained in service through the Persian Gulf War and numerous other conflicts, although it suffered from reliability problems that frustrated many users and was eventually replaced by the Belgian-designed M240. The M60 served for decades. Some variants remain in use with specialized units even today. The M60's lineage traced directly back to the factory in Doblin, where engineers who once made lanterns decided to build machine guns. The Belgian FNMAG, adopted by the United States as the M240, also owed a significant design debt to the MG-42 concept. The very idea of a general-purpose machine gun, a single weapon adaptable to multiple battlefield roles, came directly from a German Einheit Smashdinge concept that produced first the MG-34 and then the MG-42. Designers of the FNMAG explicitly studied German wartime weapons and incorporated the lessons they offered. The French MAS-52 copied the MG-42's feed system almost outright. The Swiss MG-51 was essentially a refined and improved MG-42. Austria's MG-74 was a direct descendant. Spain's AME incorporated MG-42 principles into a lighter weapon chambered for NATO standard ammunition. Yugoslavia produced the MG-42 as the M53, using captured German machinery and manufacturing documentation seized by the Soviets at the end of the war. These weapons served in Yugoslav armed forces for decades and saw extensive use during the conflicts that followed the country's collapse in the 1990s. But the most direct descendant of the MG-42 was German. When West Germany rearmed in the late 1950s as part of NATO, the newly formed Bundeswehr needed a general-purpose machine gun. The choice was almost inevitable. Most Bundeswehr officers and senior enlisted personnel were veterans of the Wehrmacht. They had carried MG-42S throughout the war. They knew the weapon intimately. They trusted it. They had no desire to adopt an unfamiliar foreign design. There was, however, a major obstacle. The original MG-42 production documentation had been captured by Soviet forces at the end of the war. The factories that once produced the weapon had either been destroyed by Allied bombing or dismantled as part of war reparations. The skilled workers who had built the MG-42 were scattered, dead, displaced, or employed in entirely different industries. West Germany was forced to rebuild the entire capability from nothing. Rheinmetall, reconstituted as a West German company after the war, was tasked with producing a new general-purpose machine gun. But the company had no blueprints, no specifications, and no original tooling. Engineers had to reverse engineer the weapon from surviving examples. One MG-42 was obtained from a museum in the United States. Rheinmetall engineers disassembled it completely, measuring every component down to fractions of a millimeter. From those measurements, they recreated detailed manufacturing drawings. New tooling was designed based entirely on these reverse-engineered specifications. The West German government paid royalties to Johannes Grossfuss for the legal right to manufacture weapons based on the original design. The manufacturing knowledge Werner Gruner and his team had developed remained protected intellectual property even decades after the war. The first post-war variant, designated the MG-1, entered production in 1958. It was rechambered for the NATO standard 7.62 by 51 mm cartridge, replacing the original German 7.92 by 57 mm round. The two cartridges shared similar ballistic characteristics and the same base diameter, making the conversion relatively straightforward. Further refinements followed. The MG-1A1 introduced chrome-lined barrels and recalibrated sights. The MG-1A2 added a heavier bolt to reduce the rate of fire. Finally, in 1968, the MG-3 was standardized. The MG-3 was, in essence, the MG-42 reborn. It retained the same stamp steel construction, the same roller locking system, the same quick-change barrel mechanism, and the same fearsome rate of fire, adjustable through different bolt weights. Parts from wartime MG-42S and modern MG-3S were largely interchangeable. A trained armorer could swap components between weapons manufactured more than 50 years apart. The MG-3 was produced under license by Italy, Greece, Iran, Pakistan, Spain, Turkey, and other nations. More than 1 million units were manufactured worldwide. Variants of the MG-42/MG-3 family have served in conflicts from the Cold War to the present day. Over 40 countries have fielded versions of the design. In the 21st century, more than 80 years after Gruner and his team submitted their stamped metal prototype, weapons descended from their work remain in active military service across the globe. The German Bundeswehr used the MG-3 as its standard general-purpose machine gun until it began replacing it with the Heckler & Koch MG-5 in the 2020s. Even then, vehicle-mounted MG-3S remained in service because the newer weapons did not fit existing mounts. Replacing all of those mounting systems would have cost more than continuing to use the proven MG-3. Turkish forces deployed MG-3 variants in operations against Kurdish militants. Pakistani troops carried the weapon along the Afghan border. Iranian forces used MG-3S extensively during the Iran-Iraq War of the 1980s. Spanish peacekeepers brought MG-3S to the Balkans. Greek soldiers continue to maintain MG-3S in their arsenals today. The weapon that terrified Allied soldiers on D-Day remains in service more than 8 decades later. Few military designs have shown such endurance. Werner Gruner survived the war. He remained in Germany and eventually settled in Dresden within the Soviet occupation zone that became East Germany. His expertise in manufacturing engineering was valuable to the communist government as it rebuilt industrial capacity. Gruner became a professor at the Technical University of Dresden, where he had studied as a young man. He rose through the academic ranks, eventually serving as rector of the university from 1950 to 1961. He trained a new generation of engineers in the manufacturing techniques he had developed before and during the war. Gruner received numerous honors from the East German government. In 1959, he was awarded the Patriotic Order of Merit. In 1961, he received the National Prize of the German Democratic Republic, second class. In 1969, he was awarded the Order of the Banner of Labor. In 1979, he was named an honorary senator of the Technical University of Dresden. Werner Gruner died in Dresden on June 29, 1995, at the age of 91. He was buried in the Waldfriedhof Weißerhirsch Cemetery in the Loschwitz district of the city. His obituaries focused on his academic career and his contributions to manufacturing technology. They noted his service as rector of a major technical university. They did not dwell on the weapon that had killed tens of thousands of Allied soldiers and established design principles still used in firearms today. Heinrich Seal also survived the war. He was captured by American forces shortly after D-Day and spent time as a prisoner of war. After Germany's surrender, he was released and returned to civilian life, working as a farmer in northern Germany. For decades, Seal rarely spoke publicly about his actions at Omaha Beach. The memories haunted him. He suffered nightmares about the man he had killed. He questioned whether he was a war criminal, whether he had committed an atrocity by firing thousands of rounds at soldiers who had little chance to fight back. He struggled to reconcile his actions with his belief that he was a decent person. He had followed orders. He had defended his position. He had done what soldiers are trained to do in war. And yet, he had killed hundreds, perhaps thousands, of young men whose only crime was wearing a different uniform. In 1963, Seal read The Longest Day by Cornelius Ryan. In its pages, he encountered the story of David Silva, a 19-year-old American infantryman from the 29th Infantry Division who had been shot 3 times in the chest while landing on the Easy Red sector of Omaha Beach. Silva had survived his wounds. After the war, he studied theology and was ordained as a Catholic priest in 1954. By the early 1960s, he was serving as a military chaplain stationed in Krefeld, Germany. Seal tracked him down and arranged a meeting. The 2 men who had been enemies on that blood-soaked morning finally came face to face. They shook hands. They spoke about the war, about what they had experienced that day, and about the years that followed. In acknowledging each other's humanity, they found a measure of peace, each other's humanity. They understood that both had been young men swept up in forces far beyond their control. Seal later published a memoir about his experiences titled WN62, named after the designation of his bunker. The book described his actions on Omaha Beach in stark, unfiltered detail that many readers found deeply unsettling. He did not glorify what he had done. He simply described it. Heinrich Seal died on January 14, 2006, at the age of 82. His memoir remains in print. The MG-42 fundamentally changed how armies think about machine guns. Before 1942, military planners drew strict lines between light machine guns for mobile operations and heavy machine guns for fixed offensive roles. The weapons were different. The tactics were different. The logistics chains were separate. The MG-42 proved that a single weapon could effectively fill multiple roles. The general-purpose machine gun became standard doctrine for every major military in the world. Today, no modern army separates light and heavy machine gun functions in the way they did before the Second World War. The weapon also demonstrated the power of manufacturing innovation. Gruner's approach, designing for production efficiency from the very beginning rather than designing a weapon first and worrying about how to build it later, reshaped military procurement for generations. Today, design for manufacturing is a foundational principle in weapons development. Engineers consider production constraints and scalability from the earliest stages of design. Perhaps most importantly, The MG42 showed that expertise in a specific field can matter less than expertise in problem solving. A mechanical engineer whose background was stamping sheet metal lanterns created one of the most effective infantry weapons in history. He succeeded precisely because he approached the problem differently from conventional weapons designers. He asked questions they never considered and found solutions they had overlooked. The factories that built MG42s are gone. The Johannes Grossfuss company no longer exists. The workers who stamped sheet metal into instruments of war have faded from living memory. The engineers who designed the weapon, the soldiers who fired it, and the men who faced it are almost all gone now. But their creation endures. Every time a soldier chambers a round in an MG3, every time an M240 opens fire in combat, every time a military planner considers general-purpose machine gun requirements, the influence of the MG42 remains. A weapon conceived in a lantern factory continues to shape how wars are fought. This is how innovation happens in warfare, not always through official research programs or established experts. Sometimes it comes from outsiders who ask different questions and refuse to accept old assumptions. A factory that made lanterns. An engineer who knew nothing about weapons. A simple idea about stamp metal that saved $100 per gun and went on to kill thousands of soldiers while shaping military technology for nearly a century. The MG42 proved that the best solutions do not always come from the obvious places. Sometimes they come from people who are too inexperienced to know what is supposed to be impossible. If you found this story informative, please take a moment to like this video. It helps us share more untold stories from military history. Subscribe to stay connected with these forgotten chapters of the past. Each one matters. Each one deserves to be remembered. We would love to hear from you. Leave a comment below telling us where you are watching from. Our community spans continents and generations, from veterans to history enthusiasts. You are part of something meaningful here. Thank you for watching, and thank you for keeping these stories alive.